June 6, 1944, Omaha Beach. Lieutenant Thomas Anderson crouches in the bow of a flat-bottomed boat charging toward the German fortified coastline at 12 knots. Around him, 36 terrified soldiers grip their rifles as machine gun fire tears through the morning fog. The boat's blunt nose crashes onto the sand, and the frontal ramp drops with a metallic clang. Within seconds, Anderson and his men pour onto Fortress Europe, the largest amphibious invasion in human history. Made possible by a design the U.S. Navy had repeatedly rejected as worthless junk. 6 years earlier, in a cramped New Orleans boatyard thick with the smell of cypress wood and engine oil, a Louisiana boat builder named Andrew Higgins stares across a desk at stone-faced Navy admirals. His flat-bottomed Eureka boat bobs in the murky Mississippi waters behind him, a design born from navigating Louisiana swamps, not winning wars. The admirals dismiss it immediately. Completely impractical for military use, they declare, favoring sleek V-hull designs from prestigious East Coast shipyards. But as one admiral walks away, a single question hangs in the humid air. How does a boat these experts called impossible become the weapon that Eisenhower credits with winning World War II? If you want to discover the untold story of innovation versus bureaucracy, hit that subscribe button and drop a comment below on which WWII story we should cover next.
May 1926, the Louisiana Delta. Andrew Jackson Higgins stands knee-deep in muddy swamp water, watching another conventional boat run aground on a sandbar barely 6 inches below the surface. The wealthy hunters and oil prospectors who hired him need vessels that can navigate these treacherous shallow waters where traditional boats simply cannot operate. Most boat builders would see an impossible challenge. Higgins sees an opportunity. Working 18-hour days in his modest New Orleans boatyard, Higgins develops the Eureka, a revolutionary shallow-draft vessel with a completely flat bottom and a protected propeller housed in a recessed tunnel. The design contradicts everything taught in prestigious naval architecture schools. No sharp bow to cut through waves, no V-shaped hull for stability. Instead, a blunt, almost crude-looking craft that experienced shipbuilders dismiss as unseaworthy the moment they see blueprints. But in the shallow bayous and marshlands of the Mississippi Delta, the Eureka performs like nothing else on the water. It glides across sandbars that would destroy conventional boats. The protected propeller tunnel allows it to operate in waters barely deep enough to float a canoe. Most remarkably, its flat bottom and blunt bow let it drive directly onto muddy banks and beaches, then reverse back into deep water without getting stuck, a capability that seems trivial until you consider military applications. 1938. Higgins sees war clouds gathering over Europe and recognizes that his swamp boat might have military value for landing troops on hostile shores. He submits his Eureka design to the U.S. Navy's Bureau of Ships in Washington, complete with performance data, photographs, and detailed specifications. The response comes swiftly and dismissively. The design lacks merit for naval operations. Bureau of Ships will proceed with proven V-hull designs from established East Coast manufacturers. The rejection letter reveals institutional thinking that would plague American military innovation throughout the pre-war years. Navy bureaucrats trust prestigious shipyards in Philadelphia and Boston, companies with generations of naval contracts and politically connected leadership. Higgins Industries occupies a converted boatyard in New Orleans, run by a loud, profane businessman whom Washington insiders consider an unsophisticated outsider. The Navy's decision reflects not just technical conservatism, but geographic and class prejudice that favors established players over radical innovation.
September 1939. Germany invades Poland and World War II explodes across Europe.
Within months, the stunning success of German blitzkrieg tactics forces American military planners to confront an uncomfortable reality. The United States possesses no effective capability for amphibious warfare. If America enters this war, forces will need to land on hostile beaches defended by entrenched enemies with modern weapons. Current military boats simply cannot do this. The Marine Corps faces the problem most urgently. Unlike the Army, Marines specialize in amphibious operations, storming beaches to establish footholds for larger invasions. But their existing landing craft are disasters. Based on old World War I designs, these boats feature high sides, V-shaped hulls, and no frontal exit. Troops must climb over the sides while under enemy fire, creating a killing zone that turns beach landings into suicide missions. Major Victor Krulak, a forward-thinking Marine officer, discovers photographs in a military journal showing Japanese forces using specialized landing craft during their invasion of China. These boats feature a revolutionary frontal ramp that drops down, allowing troops to charge directly onto beaches instead of climbing over exposed sides. Krulak immediately recognizes this as the solution the Marines desperately need and rushes the concept to military planners in Washington. But here's where bureaucratic resistance becomes deadly. The Navy's Bureau of Ships refuses to simply adopt the Japanese design or seriously consider alternatives like Higgins Boat. Instead, they commission their own design from trusted East Coast shipyards, a V-hulled landing craft that Navy engineers insist will outperform any crude flat-bottom design from Louisiana. Institutional pride and bureaucratic turf protection trump practical battlefield needs. May 1940. The Bureau of Ships organizes a competitive trial, where their new V-hulled boat will face off against 3 civilian designs, including Higgins' modified Eureka. The testing takes place in Chesapeake Bay, under conditions Navy officials consider realistic for military operations. Higgins arrives from New Orleans with his boat loaded on a flatbed truck, knowing this represents his last chance to overcome the institutional bias working against him. The Navy's V-hulled boat looks impressive: sleek lines, high gunnels, professionally finished in military gray paint. The Higgins boat looks crude by comparison: flat, blunt, utilitarian. Navy officials make no secret of their expectations. Their vessel will validate years of careful engineering by America's finest naval architects. The Louisiana swamp boat will be exposed as inadequate for serious military use, and this embarrassing episode can finally be closed. The first test involves approaching a beach through calm water, landing, discharging imaginary troops, then retracting back into navigable depth. The Navy boat goes first. Its V-hull cuts smoothly through the water, and the vessel makes a textbook approach to the beach. But the moment the sharp bow touches sand, the boat stops dead in shallow water, still 15 feet from dry land. Attempts to drive it further onto the beach cause the unprotected propeller to dig into the bottom, throwing sand and nearly damaging the shaft. The boat cannot complete the test. Higgins' Eureka executes the same approach with its flat bottom planing across the surface. The blunt bow drives directly onto the beach until the entire craft rests on sand in water barely 6 inches deep. The protected propeller continues running without damage. When time comes to retract, the boat simply reverses, its flat bottom sliding easily back into deep water. The difference is not marginal, it's absolute. One design works, the other fails completely.
Despite overwhelming evidence from the trials, Navy bureaucrats refuse to surrender. They schedule additional tests, modify their failed V-hull design, and continue insisting that proper naval architecture will eventually triumph over Higgins' crude approach. Months pass while Marines train with inadequate equipment and war spreads across Europe and Asia. The institutional resistance seems unstoppable until the Marine Corps takes extraordinary action. Marine Lieutenant Colonel Lewis Puller,
A decorated veteran already legendary for his combat leadership personally intervenes with Navy leadership. His message is blunt and insubordinate. Your boats are getting Marines killed in training. We need the Higgins boat, and we need it now. The Marine Corps threatens to procure landing craft through separate channels, bypassing Navy control entirely, a bureaucratic nuclear option that finally forces compromise. November 1940. Andrew Higgins receives a contract for preliminary production of his landing craft, now designated the LCVP, Landing Craft, Vehicle, Personnel. But the victory comes with frustrating conditions. Navy specifications require changes to Higgins' proven design, including dimensional modifications to fit existing shipboard davits and the addition of armor plating that Higgins argues will compromise the boat's shallow draft performance. Every improvement the Navy demands seems calculated to make the boat more like their failed V-hull design. The most critical modification comes from the Marines themselves. Officers who studied the Japanese landing craft photographs insist that the Higgins boat needs a frontal ramp that can drop down to allow rapid troop discharge. Higgins initially resists, arguing that his boats already perform this function adequately. But after seeing demonstrations of how much faster troops can exit through a bow ramp versus climbing over the sides, he becomes the innovation's fiercest advocate. Creating a reliable bow ramp mechanism proves extraordinarily challenging. The ramp must seal tightly during transit to prevent swamping in rough seas, yet drop instantly and reliably when the boat beaches. It must support the weight of troops charging across it, yet be light enough that one man can operate it manually if hydraulics fail. Most critically, it must survive the violent shock of driving onto beaches at full speed, often striking rocks or coral that would destroy delicate mechanisms. Working literally around the clock, Higgins and his engineers develop a remarkably simple solution: a heavy-duty ramp suspended by cables with a manual release that allows gravity to drop it the moment the boat beaches. No complex hydraulics to fail, no electrical components to corrode in salt spray, just robust mechanical engineering that a 19-year-old sailor can operate under the worst combat conditions imaginable. The design is pure Higgins, functional, reliable, and utterly without pretension.
August 7, 1942. Guadalcanal. The first major American amphibious offensive in the Pacific theater tests the Higgins boat under actual combat conditions. Marines huddled in the LCVPs as they approach hostile beaches defended by Japanese forces don't know they're riding into history. Most are terrified teenagers who've never experienced combat, and many won't survive the day. But the boats carrying them perform flawlessly. The flat bottoms allow the Higgins boats to navigate Guadalcanal's treacherous coral reefs that would have torn apart traditional V-hull craft. The protected propellers continue running even when crossing reefs barely covered by water. Most critically, the bow ramps drop instantly when the boats beach, allowing Marines to charge directly onto the sand instead of climbing over exposed sides while under fire. The difference between life and death literally comes down to those few seconds of reduced exposure. After-action reports from Guadalcanal read like vindication for everything Higgins fought to achieve. Marine commanders report that the LCVP's performance exceeded all expectations. Casualty rates during the beach landings are significantly lower than predicted, largely because troops can exit the boat so quickly. Even when boats take direct hits from Japanese artillery, the simple, robust construction means many remain operational enough to limp back to transport ships for repairs. But Guadalcanal also reveals a critical limitation. The LCVP can carry 36 troops or a jeep, but it cannot transport tanks or heavy artillery. For the island-hopping campaign that will carry American forces across the Pacific, something larger is needed. A vehicle-carrying version of the Higgins boat that can deliver the heavy weapons necessary to overcome fortified Japanese positions. The Navy's Bureau of Ships sees an opportunity to reclaim control of landing craft development. They commission a tank-carrying design from their trusted East Coast shipyards, fully expecting to finally demonstrate that proper naval architecture will outperform Higgins' crude approaches. But Andrew Higgins moves faster than Navy bureaucracy. Within months, his boatyard produces the LCM, Landing Craft Mechanized, essentially a scaled-up version of the LCVP that can carry a 30-ton tank directly onto hostile beaches. The design process reveals Higgins' genius for practical engineering. Rather than creating an entirely new vessel, he simply applies the proven principles of the LCVP to a larger platform. Flat bottom for shallow draft, protected propeller for coral reef operations, frontal ramp for rapid vehicle discharge. The result is a boat that looks unsophisticated but performs reliably under the worst conditions imaginable. Navy engineers privately admit the design is brilliant in its simplicity, even as institutional pride prevents public acknowledgement.
Production of Higgins boats becomes an industrial phenomenon that rivals the Liberty ship program in scale and importance. At peak production in 1943, Higgins Industries employs over 20,000 workers in New Orleans, operating 7 boatyards that together produce more than 700 landing craft per month. The workforce includes thousands of women and African Americans in skilled positions traditionally closed to them, making Higgins one of the war's unlikely pioneers in industrial integration. June 6, 1944, D-Day. More than 1,500 Higgins boats carry the first waves of American forces onto Normandy's beaches, the largest amphibious invasion in human history, made possible by a design Navy bureaucrats once dismissed as worthless. On Omaha Beach alone, where German defenses inflict horrific casualties, the ability of LCVPs to drive directly onto the sand and rapidly discharge troops prevents even greater losses. Military historians later calculate that traditional landing craft would have made the invasion impossible. The Pacific Theater tells the same story across dozens of island assaults: Tarawa, Saipan, Iwo Jima, Okinawa. Every amphibious operation depends absolutely on Higgins boats to carry Marines across coral reefs and onto defended beaches. Japanese forces prepare elaborate defensive positions calculated to destroy landing craft in shallow water, but the flat-bottom design and protected propellers of the LCVP allow American forces to overcome obstacles that would have stopped conventional boats completely. General Dwight D. Eisenhower, Supreme Allied Commander, later makes a statement that validates everything Higgins fought for. Andrew Higgins is the man who won the war for us. If Higgins had not designed and built those LCVPs, we never could have landed over an open beach. The whole strategy of the war would have been different. Coming from the officer who commanded both the European and North African campaigns, the assessment carries enormous weight. Final production numbers tell the quantitative story. Higgins Industries ultimately produces more than 20,000 landing craft of various types, roughly 92% of all U.S. Navy landing craft used during World War II. The boats participate in every major amphibious operation in both the Atlantic and Pacific theaters. Their combined contribution to Allied victory is incalculable, as the entire strategy of island hopping in the Pacific and the invasion of occupied Europe depends on the capability to land troops and vehicles on hostile beaches. Yet Andrew Higgins never receives the recognition given to more celebrated industrialists like Henry Kaiser, or the public adulation afforded to military leaders. The Navy's institutional resistance continues even after overwhelming battlefield validation. Official histories minimize Higgins' contributions, crediting American industrial capacity rather than the specific innovation and determination of one Louisiana boat builder who refused to accept bureaucratic rejection. The boats that won the war came from a man the establishment never wanted to acknowledge. Higgins dies in 1952, his company bankrupt after post-war Navy contracts mysteriously dry up despite decades of proven performance. The final insult comes when the Navy commissions landing craft designs from these same East Coast shipyards that failed competitive trials in 1940, completing the institutional victory that battlefield reality had denied. But the boats themselves, many still operating in military service decades later, stand as permanent testimony to a simple truth: innovation often comes from unexpected places, and bureaucracy's greatest enemy is someone who simply refuses to quit.